Hello everyone. Welcome to the course of lecture Testing and Commissioning of Electrical Equipment. Here we are in lecture number 38 about synchronous machines, introduction and the basic concepts of synchronous machine. So in this module we are going to see about specification, acceptance test, location, mounting, installation, then commissioning process, then how to find the insulation resistance, then temperature rise, cooling system, enclosures, everything. We will see in this synchronous machines. That is module 5. First, what is synchronous machine? And what are the difference between synchronous machine and induction machine? That we have to know. It is an AC machine whose speed is proportional to frequency of armature current. The speed under steady state condition is called synchronous speed. The synchronous machine always run at synchronous speed and it has no slip. Synchronous machine includes synchronous generator, synchronous motor and synchronous condenser. So it has three-phase distributed windings on stator and DC excited field poles on rotor. So excitation system supplies DC current to field windings. Generally, the synchronous machine and the exciter for supplying DC to rotor field winding are mounted on the same shaft. The slip of a synchronous machine under steady state operating condition is always zero. So here, synchronous machines are AC machine that have field circuit supplied by an external DC source. So DC current is applied to rotor winding producing rotor magnetic field. The rotor is then turned by external means producing a rotating magnetic field which includes three-phase voltage within the stator winding. In synchronous motor, three-phase set of stator currents produces a rotating magnetic field causing the rotor magnetic field to align with it. The rotor magnetic field is produced by the DC current applied to the rotor winding. So field windings or winding producing the main magnetic field. Armature windings are the winding where main voltage is induced. So we have two things, field windings and armature winding. That is called rotor and stator respectively. So this is the constructional features of synchronous machine. So for example, synchronous rotor with 8 salient pole that is shown in figure. So salient pole with field winding, that is, okay, this is a projected pole or thing. And here we have two types of rotor, right? That is salient pole rotor and cylindrical type rotor. So this is all about salient type. So salient pole without field winding, observe the laminations here. So this is a bigger machine having a salient pole rotor. So for large generator and motor, brushless exciters are used. So what is brushless exciter? It is a small AC generator whose field circuits are mounted on the stator and armature circuits are mounted on the rotor circuit. The exciter generator three-phase output is rectified to DC by a three-phase rectifier that is also mounted on the same shaft and fed into the main DC field circuit. It is possible to adjust the field current on the main machine by controlling the small DC field current of the exciter generator that will be located on the stator. So here no mechanical contact occurs between the rotor and the stator, and exciters of this type require much less maintenance. So that for large generator and motor, brushless exciter are used. So this is another construction with the exciting system. So here brushless exciter is mounted on the same shaft This is a large synchronous machine. Here, the brushless exciter system is mounted on the shaft. So many synchronous generators having brushless exciter also include slip ring and brushes to provide emergency source of the field DC current. It is additional exciter system. So here you are seeing one synchronous machine with a synchronous rotor and also the exciter. This is salient pole construction by General Electric Motors. So this is a another construction of synchronous machine. See here brush assembly is also there. Here also the brush assembly, it supplies DC current to the rotor. Okay, so this is a rotor of the brushed exciter system. So it consists of two sets of winding, three-phase armature winding on the stator distributed with centers 120-degree apart in space, field winding on the rotor supplied by DC. The two basic rotor structures are used, that is salient or projected pole, cylindrical or round rotor pole. So salient poles have concentrated field winding. It usually carry damper windings on the pole face. But cylindrical and round rotor having solid steel rotor with distributed windings. So nearly sinusoidal space distribution of flux waves obtained by distributing the stator winding and field winding in many slots, shaping the pole faces. Why? Because in order to have a smooth operation, sinusoidal space distribution means we don't have any torque pulsation, torque oscillations. So for that we need to do distributing the stator winding and field winding in many slots, and also the pole salient pole phases should be in a equal shape. So another types are also there, that is hydro generators, turbo generator, engine driven generators, hydraulic turbines, steam turbine, diesel turbine. Okay, these prime movers for the synchronous generators are this thing. Okay, first three types, hydro generators, turbo generator and engine driven generators are used for the hydro stations. Okay, so here it is a somewhat bigger machines. We have the different speed ranges. So these are all prime movers: hydraulic turbine, steam turbine, diesel turbine. So hydraulic have three different things: Pelton, Francis, and Kaplan. Steam turbines run by turbo generators and turbo alternators. It is otherwise called turbo alternators. Or to be run at very high speed to get higher efficiency. And hence these types of generators are run at higher speeds. So steam turbine maximum used in generating stations. Diesel engines are used as prime movers for very small rated generator for industrial application. So again, stator construction. It is the outer part of the machine, consists of cylindrical frame called yoke, which is made either welded sheet steel, cast iron. On magnetic part, which comprises of set of slotted steel lamination called stator core, pressed into the cylindrical space inside the outer frame. The magnetic part is laminated to reduce eddy current, reducing losses and heating. So a set of insulated electrical winding are placed inside the slots of the laminated stator. Suppose in the case of generator where the diameter is too large, stator lamination cannot be punched in on circular piece. In that case, the laminations are punched in segments. A number of segments are assembled together to form one circular lamination. Okay, here the lamination, how the lamination in synchronous machine. So each and every laminations are insulated from each other by thin layer of varnish. So common approaches are used to supply a DC current for excitation. First one, supply the DC power from an external DC source to the rotor by means of slip rings and brushes. Another one, supply DC power from a special DC power source mounted directly on the shaft of the machine. So here, slip ring and metal rings completely encircling the shaft of the machine but insulated from it. One end of the DC rotor winding is connected to each of the two slip rings on the machine shaft. In some machine, graphite-like carbon brushes connected to the DC terminals ride on each slip ring, supplying DC voltage to field winding. What does this mean? Some of the material is used in slip rings to reduce the losses. So in smaller machine or medium range machine, we can use a brushless excitation. For large machine and also for frequent operated machine, we need a DC excitation system. So at the time, slip rings are made up of some material, carbon brushes, graphite, like that. So what are the limitations of slip ring and brushes? So here it induces some friction and wear. So brush voltage drop can introduce some significant power losses. But for the slip ring and brush assembly is adopted for small synchronous machine. Already I told. Here, similar to induction machine and transformer, synchronous machine specification is also needed for noting down the tender, right? Specification involves rated voltage, power rating, excitation voltage, excitation current, speed, cooling system, type of rotor, short circuit ratio, then what type of insulation class, temperature limits, connections, frequency. So some ranges is also there. So we have to initially indicate the technical specification of synchronous machine. So here power rating for turbo generator and hydro generator is given. So in the previous slide, we have seen what are the specification. The same thing is noted in this table also. So power rating for two different machine, right? Just go through it. Then after that, the main important topic is installation, foundation and installation of synchronous machine. So first physical inspection is needed. So first this area selection is needed. There we have to check the damage and missing of the parts and machine to be stored in a safe place. That physical inspection is mainly needed. For foundation, based on the type of mounting, horizontal, vertical, generally alternators are mounted in vertically covering two floors, basement and ground. Okay, so we have two types, horizontal mounting and vertical mounting based on the machine. Okay, that is specification of the machine. We can mount or install the machine accordingly. The basic dimension need to be provided by the manufacturer. So provided with holes to receive fixed bolts securing the bed plates. Holes and anchor bolts should be fixed in the concrete. Here you see foundation details of ABB synchronous motor. Here we have the level bed arrangement. Some of the bolts here: vertical jacking bolt, anchoring bolt, horizontal jacking bolt, holding down bolt, pre-drilled down pin hole. So these are all the parts of that bed plate. Okay, the ground level, it is from the ground level, above the ground level. So these bolts are needed for mounting the machine. The customer is responsible for ensuring that the foundation is dimensioned correctly. Factors to be taken into consideration include local conditions, prevailing forces, routing of pipes and cables, and need to ensure that service and maintenance can be performed. Then what are the steps are needed for installation of alternator? First, initially the bed plate, that the previous slide blue color denote the bed plate, right? So first install the bed plate with leveling of bed plate. The leveling also to be considered. After that, install bearing pedestals, leveling of bearing pedestals. Then check on rotor and stator, everything in a good condition or not. Assembly of the rotor onto the shaft. Installation of stator. Then installing the rotor in the stator. Checking of air gap between stator and rotor. Preparation of shaft coupling. Mounting of shaft coupling on shaft. Then preparation of shaft and alignment of shaft. That is the main thing, right? Shaft positioning. Then installation of cooling system. Then drying out procedures. After that, several tests are there that we have to taken care of. Finally, commissioning of the synchronous machine taking place. Then after installation, to start the synchronous generator, it is needed synchronous machine, right? So this process is slow and complex. Why? Because it needs three processes, that is starting of the boiler, turbine auxiliaries, boiler auxiliaries. So from cold means what? From the initial stage, starting stage. Okay. At the time, starting of boiler, auxiliaries, starting of turbine and auxiliaries, starting of boiler, roll turbine. These are all the process needed. Keep the unit as spinning reverse. That means to start the machine from initial stage, that is from cold. So here in this lecture we have seen the specification, a total all about construction and working principle. Then what is exciter, excitation system, and stator, construction of the synchronous machine with slip ring and brush assembly. Then what are the technical specification for two different motors. Then physical inspection, foundation details. Then how the foundation may be. After foundation, the installation process, what are the steps for installation. Then procedure for starting. After installation, we need to start the synchronous generator, right? So those things needed. So these are all the topics we have seen in this lecture. So next class we will see about three-phase synchronous machine and its brushless exciter system and some other additional features of the synchronous machine, and what about synchronous speed and the principle. Everything we will see in the next lecture. Thank you all.